In this video, we're going to talk about differentiation and integration of power series. Recall that the power series that has a center at x equals 0 looks like this. Now in this book, instead of a of n, we're using c of n. So it might be a little different from the expression that we use in another video. So don't get confused. Now this power series is centered at x equals a. Remember, we used to say x equals c, but in this book, we use x equals a. And the c of 0, c of 1, c of 2 becomes the coefficients. And c of n times the quantity x minus a to the power of n is the nth term. Now let's talk about term-by-term differentiation. If you have f of x equals summation of n equals 0 to infinity of c of n times the quantity x minus a to the power of n. And when you expand it, you get these terms. And this converges for absolute value of x minus a is less than r, where r represents the radius of convergence. Now, when you take the derivative of this, in other words, we're trying to find f prime of x. F prime of x will be this right here. Now think about it. When you take the derivative, applying the power rule, you get n times c of n times the quantity x minus a to the power of n minus 1. Now notice, you need to now start from n equals 1 because look at the terms now. What's the derivative of c of 0? That's a constant. Derivative of c of 0 will be 0. And what's the derivative of this? That will be just c1. And what's the derivative of that? That's going to be 2c2 times the quantity x minus a, and so forth. So even though you take the derivative, the radius of convergence stays the same. Let's say f of x equals 1 over 1 minus x. And you know that this is one of the important Maclaurin series, which gives you the power series of this. Now, let's say you want to find the derivative of f of x. Now, that will be the same thing as derivative of 1 over 1 minus x, which will be the same thing as the derivative of this whole expression. So now, what is the derivative of 1 over 1 minus x? Well, let's rewrite this as quantity 1 minus x to the negative 1. Let's call this y. And what is y prime? Y prime will be negative times 1 minus x to the negative 2. Now, don't forget the chain rule. What's the derivative inside? Negative 1. So negative times negative is positive. You get 1 over quantity 1 minus x squared. So derivative of that is 1 over quantity 1 minus x squared. Now what about the derivative of this expression? Well, it's going to be derivative of 1 is 0, derivative of x is 1, derivative of x squared is going to be 2x, derivative of x cubed will be positive 3x squared, and so forth. And the derivative of this general term will be n times x to the n minus 1. And then plus, there are more terms. This is the derivative of f of x. And this is the power series of f prime of x. Now, let's take a look at term-by-term integration. So you have f of x equals summation of 0 to infinity of c of n, quantity x minus a to the power of n, and this is the power series, where it converges for absolute value of x minus a is less than r, which is the radius of convergence. Now, when you take the integration of this, notice, you got to add 1 to the exponent. So this becomes n plus 1, so divided by n plus 1. And c of n was already there. What is the antiderivative of c of 0? Or integral of c of 0? It's going to be c of 0 times the quantity x minus a Now, the common mistake is a lot of times the students put c of 0 times x. But remember, you need to worry about the center. It will be x minus whatever the center is. And the rest of the terms are pretty obvious. You just have to take the integration of each term. Now, also, when you integrate, you need to do integral of a to x of f of t dt on that interval. And you understand better when I do an example of what I mean. And also, after the integration, the radius of convergence stays the same. So we have f of x equals 1 over 1 plus x. This is one of the 5 important Maclaurin series that you need to recognize. And the power series for this function is 1 minus x plus x squared and so forth. And where is the center for this power series? The center is at 0. In order to find the antiderivative of f of x, you need to go from center, which is 0, to x, and you need to change the variable to t. So it needs to be f of t dt, which is going to be integral of 0 to x, 1 over 1 plus t dt. And on the right side, it's going to be integral from 0 to x. And instead of that, we got to change it to t. So you get this. So the antiderivative of that will be natural log of quantity 1 plus t from 0 to x. And what about this part right here? Well, the antiderivative of 1 is t, and antiderivative of negative t is negative t squared over 2, and so forth. And antiderivative of that will be negative 1 to the power of n is just a constant. So it will be t to the n plus 1 over n plus 1 from 0 to x. So when you take the integral of that, you get natural log of quantity 1 plus x minus natural log of 1. And you know that natural log of 1 is 0. What about over here? And over here, when you take the integral, you get x minus x squared over 2 plus x cubed over 3, and so forth, minus, you got to plug in 0 instead of t. When you do that, you get a bunch of zeros. So you end up getting natural log of quantity 1 plus x is x minus x squared over 2 plus x cubed over 3, and so forth. So this becomes the power series of natural log of quantity 1 plus x. Let's say you have f of x, which is summation from n equals 1 to infinity of x to the power of n over n, which is equal to this power series right here. Now, how would you find f prime of x, the derivative of this function? Well, let's find the derivative of each term. So what do you get? 1 plus x plus x squared, and so forth. So that will be just n cancels out, you get x to the n minus 1. Now, what about the summation? The derivative of that will be just x to the n minus 1. Now, where do we start from? How can we get 1? When n equals 1, when you plug it in, 1 minus 1 is 0, x to the 0 is 1. And this one goes to infinity. What about when n equals 2? Well, that's just x. When n equals 3 is x squared. So this is good. It works out. So derivative of f of x will be this right here. And this is the power series of f prime of x. Now, how are you going to find the integral of f of x? The integral of f of x will be same thing as integral of 0 to x of f of t dt. Because the center is at 0, So we need to start from 0. If the center is 2, then you got to go from 2 to x. So you get integral from 0 to x. Now instead of the variable x, you got to change it to t. And don't forget dt at the end. And when you take the integration of this, and you get t squared over 2 plus t cubed over 3 times 2 plus t to the 4th over 4 times 3 plus t to the n plus 1 over quantity n plus 1 times n and so forth from 0 to x. And then we need to plug in x and then subtract after plugging 0. You get this. Notice when you plug in x, all the variables of t turns to x, minus when you plug in 0, all the term goes to 0. So this is the power series for the integral of f of x. Now, how can we use summation to describe this power series? Using summation, we know that the n has to start from 1 because we have to get 2. When you plug in 1, you get 2, and you get the power of 2. And when n equals 2, you get 3 times 2 on the bottom, and you get the power of 3, and so forth. So this is using the summation notation to express the power series.